Okay, so the goal of this video is to look at the double angle half angles and primarily the double angles to start with. Okay, so um, similar to the sum and differences, you notice that we have three double angles, sine, cosine, tangent, or I should say three functions for them, with the understanding that for cosecant, for secant, and cotangent, you would just take the reciprocals. And then same thing for sine, cosine, and tangent for the half angles. Okay, so we're going to focus on the three double angle formulas. Okay, so sine, cosine, and tangent. And actually, they're super easy to prove. They come from the sums. Like if you think about for sine of alpha plus beta, which we said is sine alpha cosine beta plus sine of beta cosine alpha. Well, if alpha and beta just happen to be the exact same angles, then like call that theta and theta. Then it's sine of the first angle theta, cosine of the second angle theta, and then plus sine of the second angle theta, cosine of the first angle theta. In other words, it's the same formula, right? Sine theta, cosine theta, or 2 sine theta, cosine theta. Okay? And same thing for cosine of 2 theta and tangent of 2 theta, in that you get those formulas from the exact same way. Now, because of the Pythagorean identity for sine squareds and cosine squareds, there's actually three variations of the half angle form or of the double angle formula. All of them work. And I would also say be cautious, right? Throw the caution flag. This is close to sine squared theta plus cosine squared theta equals 1, but it's not. So we can't say it's -1. It's the difference with cosine being first. And again, you might wonder why, or where did it come from? But again, think about the cosine of alpha plus beta's formula, right? Cosine of alpha plus beta's formula is equal to cosine alpha cosine beta minus sine alpha sine of beta. So the cosine sine or cosine squared, because these become the same angle, sine squared. Okay, so we're going to jump around a bit and focus on the double angles first. Okay, so let's maybe go down to, I like this one, example 3. It gives us some information about alpha and for beta. So let's draw them. Right? So first of all, it says sine of alpha is -5/13, and it lives in the third quadrant. So here we go, making a third quadrant angle, -5/13. Let's call this alpha. And it's a great triangle. Opposite missing leg is -12, right? 5, 12, 13 triangle. Okay. And we might as well just get a picture of beta too, just to have next door, so to speak. Beta lives in quadrant 4, and he looks like he's a 3, 4, 5 triangle. So label it beta. Cosine, so 4 to 5, with the missing leg of -3. Okay, so first problem, sine of 2 alpha. Okay, well, sine of 2 alpha, we would expand and just say it's 2 sine alpha cosine alpha. So again, have to know that formula. We don't have to ever prove it again, but that we could know where it comes from. So then we just have to look at our alpha with just one triangle. And so we multiply 2 times sine of alpha, which we knew was -5/13, and cosine of alpha, which is -12/13. Overall, it's going to be positive. 120 is the numerator, 2 times 5 times 12, and 13 squared, 169. So there's our sine of 2 alpha. And the great thing about this is that the formula automatically accounts for whether it's positive or negative. I mean, think about alpha is an angle that's between 180 and 270, and you're doubling it to something between 360 and 540. It's a huge range, but based on the ratio, we know it's going to be a positive 120 over 169. Okay, let's jump down to another double angle. B and C are half angles. Aha, D, double. Okay, so tangent of 2 beta. So again, knowing that formula, tangent of 2 beta starts off with 2 tangent of beta. divided by 1 minus the square of the tangent. And again, that comes from the formula tangent alpha plus tangent beta minus 1 minus tangent alpha tangent beta. Okay, let's go grab tangent of beta. I think it's the green triangle, ironically. So here's beta. The tangent of it is negative 3/4. So coming down here. And so we know that we'll get 2 times negative 3/4 divided by 1 minus the quantity of negative 3/4 squared. Let's be careful in the math here. 2 times negative 3/4 is negative 6/4, and I could simplify that. And then this 1 minus 9/16. Or that's negative 3/2 divided by, well, 1 minus 9/16, that's 16 minus 9/16, or 7/16. And then when you divide by a fraction, you could also multiply by its reciprocal. So negative 3/2 times 16/7. That's not too bad. The 2 goes into 16 8 times, and so we get negative 24/7. Okay, so another double angle example. I think let's do a couple more. A new scenario. They give us just theta, and they ask us for sine of 2 theta, cosine 2 theta. And by the way, I'll come back and we will solve the half angles in the next video. Just wanted to focus on the doubles to start with. Okay, so again, worth our while to draw the picture of what theta is. So looks like we have a fourth quadrant angle this time for sine. Negative 1 to 3. So it's not a 30, 60, 90, or sorry, it's not a 3, 4, 5 or anything like that, but it's okay. Pythagorean theorem, square root of 9 minus 1. So we know the missing leg is root 8, or simplified to root 2. It'll be positive. Okay, sine of 2 theta. Maybe you know it. You could write it out. I always think that that's the easiest of them. I'm not sure why. 2 sine theta, cosine theta. And then we just substitute in. So remember, theta's up here. Sine of theta was negative 1/3. And cosine of theta, 2 root 2/3. Simplifying to 4, so negative 4 root 2/9. Okay. Now, cosine of 2 theta. Really, it's your choice. All of them work. The main one, or the one that we get directly, is cosine squared theta minus sine squared theta. A lot of students use that one, and that's great. So you could say cosine squared theta, so 2 root 2/3 squared minus sine squared theta, negative 1/3 squared. That's 8/9 minus a positive 1/9, which is 7/9. Okay. Now, why are there other variations? I think just to show equivalencies, but here's a suggestion, here's a thought. The given was that sine of theta is negative 1/3. So I could actually build cosine of 2 theta only knowing sine theta because, because I know that one of the variations is 1 minus 2 sine squared theta. That's one of the variations of cosine 2 theta. And it's the one that only is based on sine. So maybe that could have saved you. Maybe it made your calculations a little bit more efficient. I don't know. So it's negative 1/3 squared. So we're just going to do it again for fun. 1 minus 2 times 1/9. 1 minus 2/9. No surprise here. We get 7/9, which is what we had before. Okay, so I think those are all the doubles that we have, I believe, so far. You can either take a pause and do some of the double angles on the homework, or you could watch the next video, which we'll start looking at some of the half angle formulas.